Welcome, Cosmic Comrades. You already know who I am. If you don't, you've probably seen me before. And if you haven't seen me before, you should probably watch my other videos. You might be wondering why there's this whole empty space right next to me. That's for a reason.
Hi!
As you can see, we have a very special guest with us. Would you like to introduce yourself, very special guest?
Hi, I'm...
What is our topic today?
Today we will discuss why the cosmic speed limit, aka the speed of light, is not a suggestion, it's the law.
Wow, that is a dense topic, so you should probably prepare yourself. Are you prepared?
Yep,
Okay.
give me some big words.
Alright. Have you heard of Albert Einstein?
Yeah, I heard he's a genius.
Really?
At least that's what they tell us in school.
Yeah, I think I've heard that as well. Well, he was a German physicist, for those who don't know, of the early to mid 20th century. One of his most important contributions to modern physics today is his theory of relativity, both special and general relativity. Alright, with special relativity that Einstein produced, Einstein postulated that the speed of light will remain constant in all reference frames that are moving at a constant velocity. For you to feel the full weight of that postulate, I will discuss how it contrasts, or I guess augments, classical relativity. Consider you're cruising down the highway at 27 meters per second, or 97 kilometers an hour, or 60 miles per hour. But we're physicists here, so we use meters per second. Anyway, someone is zooming down the highway at 31 meters per second. You will measure their speed relative to you as 4 meters per second. Simple enough.
Seems simple.
The speed of light is 299,792,458 meters per second, abbreviated often as the constant c. Say you're in a spaceship going 0.5 times the speed of light. You have your headlights on. Perhaps you're trying to find dark matter. Don't try this, by the way, it's not going to work. You're just going to waste your time. But the beam of light in your direction of travel will still be traveling at exactly c for you in the spaceship, as well as someone watching you waste your time. You can pause a second here to let that sink in. Alright, back to learning. Many consequences arise from this fact. One consequence is time dilation. What is all this time dilation nonsense? Say your friend is on a moving train, operating a device that will send a pulse of light directly from the bottom of the train to the top of the train and reflect back down and hit the device. This friend contacts you and tells you to make it to the train station platform, which he's about to pass really quickly at relativistic speeds, close to the speed of light. So you book it on over to the train station, which is annoying because you have to pay for the train ticket that you're not going to get on. But he tells you to bring an atomic clock, but you only have an atomic watch, so that'll have to do. But with insane precision and reaction time, you and your friend sync your clocks at the exact time the light pulse device thing reaches your position in the station. In precisely that same moment, your friend presses a button which activates the device. You both measure the time it takes for the light pulse to hit the device. And of course, measure the same time, right?
Yeah?
Nope.
Okay.
You measure the same speed of light, yeah. But being on the platform, you measure the light to have traveled a greater distance in order to reach the bottom of the train car again. This means, in order to maintain the constant speed of light, you measure that the time it took for the light pulse to make it back to the bottom of the train car is greater dependent on the speed of the train. Besides the fact that your friend is well beyond escape velocity and is hurling it into the sun, you two are having a shouting match because you can't agree on a time. In physics, when we're dealing with relativity, well, with special relativity, we often use a speed-dependent factor, which we abbreviate as gamma.
Whoa, I did not come here to learn Greek letters too.
Yeah, well, I didn't either, but we ran out of Latin letters. I'd rather not get into Greek either. I barely passed it being fluent in English. But unless you want to write the full factor, which happens to be 1 over the square root of 1 minus v squared over c squared, 50 bajillion and 4 times, here we are.
I think I'm good.
That's what I thought. The important part about gamma is that it increases as the velocity increases. And in particular, it gets close to the speed of light c. As you can see from the full description of the factor, as v, or when v is the same as c, you get 0 in the denominator, which is illegal. In math, that is known as illegal. We don't like that. So 99% of the math that we're doing would fall apart if you're at the speed of light. Similarly, for an observer faster than the speed of light, the denominator will have a negative square root, which we don't like in math either, unless we're dealing with imaginary numbers. And in quantum physics, we got to do that a lot. But we're not in that. Not now. Please not now. Alright, so also from the postulate that the speed of light c is constant in all reference frames, it violates logic as well, if we are moving at the speed of light. For any observer moving at the speed of light, their own speed relative to themselves is 0. That's fine, right?
Mm-hmm.
Because of relativity. But if they are moving at the speed of light, again, speed of light, c, is always the speed of light for anyone in any reference frame. So if they are moving at the speed of light, their own speed will be both 0 because of normal relativity, and it'll also be the non-zero c. That's the problem. You don't do that.
Nope.
No one can go to the speed of light. As a matter of fact, I'll go a step further and say that nothing with mass can travel the speed of light. Let's build up to the reason why. Alright, so there's a chance that you might have heard of Einstein, I guess. But there's no way you've heard of this equation he produced, E equals mc squared.
Heard of it. Definitely heard of it.
Whatever. But I bet you haven't heard the full story though. E equals mc squared describes the fact that inertial mass is essentially stored energy. This only describes the rest state of an object. So, as we knew back in the Newtonian days before all this mess happened, the gamma factor. As the mass of an object increases, the force required to accelerate an object a given amount increases as well. Well, this still applies. Since the energy/mass of an object increases with speed until it reaches the speed of light, at which point it will have infinite energy/mass given that gamma factor, it will become increasingly difficult to accelerate this object as it approaches light speed, given both that it is impossible for anything to have infinite energy, because infinity is a big number, and that infinite mass will make it impossible to accelerate anymore. Anything with mass cannot go light speed. And so as if you needed any more reason why going to light speed, not to mention faster than light, is outlawed in 49 states.
Wait, what's the 50th?
Oh yeah, it's legal in Florida with the permit.
As expected.
Yeah. Let me introduce you to causality. Causality is relatively intuitive. Let's say event A causes event B. Event A will have to happen before event B in order to cause it. That's fine. The universe likes to uphold this causality thing. Alright, so you remember your friend who got hurled into the sun on that train?
Johnny.
Yeah. It's tragic. Let's say when that happened, there was a little mini explosion that you could detect from Earth. Light traveled to the Earth from that explosion. Let's call that explosion event A. Okay? And let's say there is a satellite orbiting the sun at that time, or it detected the explosion from the sun, and it decided, hey, I should probably let people know about this. But the satellite wanted to communicate with Earth with faster than light travel, which is fine. If we throw out everything else I've said so far, it's fine. So yeah, it's understandable. Light takes time to travel. It's not an instant transmission. So something's going faster than it. It's no biggie. Alright, so explain why this is a problem. I'm going to introduce you with something called a space-time diagram. It relates time and space because time and space are very related. So we're going to describe the situation using this diagram. In the reference frame of the sun, the horizontal axis is the positional axis, which we labeled X. The vertical axis is the time axis, which we've actually labeled CT, so that we can measure time in units of distance. Scaling it with the speed of light, any light pulse that's recorded in this graph will have an angle of 45 degrees. So we left this dotted line, some random light pulse from position 0 and time 0, there for reference. Event A, again, is the explosion and the recording of the explosion. And the light traveled is the red line. And when Earth finds out about it from the light, we have event B. The satellite that recorded the event is sending out a signal at a speed faster than the speed of light. And so the Earth will find out about this event when this signal reaches Earth. And later on, however long this is, it'll actually see the event happen. But we need to consider other reference frames. Let's say there's an alien zooming through the solar system, and this alien is traveling very, very, very close to the speed of light. So we're gonna label his axis. All right, just zooming through the solar system, as you do. His name can be Bob, I suppose. Yay! And this is his time axis, and through this thing called Lorentz transformations and other transformations, there's the positional axis can be written as a reflection over this 45 degree angle, this light pulse. And so we're gonna just write its own positional axis there. So we want to consider units of constant time. The units of constant time are always parallel to the positional axis. So in the sun's reference frame, it's just horizontal. And for the alien's reference frame, it'll be parallel to this x prime axis. If we label these time units, we'll call it 1, 2, and 3, we can say that the signal will be sent after Earth receives the signal, which violates causality and also logic. So anything cannot travel the speed of light. Okay, now that that's over.
Wait, aren't there galaxies traveling away from us way faster than the speed of light?
Oh yeah, there's...
And what about the quantum entanglement?
Jesus, with the nuances. Okay, look, for the galaxy thing, there's no galaxy that's moving through space faster than the speed of light. Space itself is expanding, which means that further galaxies and further objects are going to be traveling away from us way faster, and closer galaxies are going to travel away from us slower. As long as nothing is traveling through space faster than the speed of light, or at the speed of light, we good. We good. Quantum entanglement, though, is actually a loaded question. But the idea is that for two particles quantumly entangled with each other, some information in one particle is reliant on the other. This information is usually in the form of spin of a particle, which is usually either spin up or spin down. And before it is measured, either particle is actually both spin up and spin down at the same time, which is weird. But that's quantum mechanics for you. Only after the measurement of the spin will the particles collapse into one state of spin. So one particle will be spin up, the other one will be spin down. And this happens instantaneously when one particle is measured, regardless of their distance. Jesus, that was extremely dense. And I don't expect you to get that all at once. So, if you have questions, leave them in the comments. I thank you so much for being here.
No problem.
We appreciate you. And if you found this video helpful in any way, go ahead, smash that like button and subscribe. Share it with anyone struggling or anyone who enjoys these concepts. But most importantly, always remember to keep wondering.
Bye!